Hello everyone, welcome to this session. Chapter is motion in straight line. And so far in our previous video, we saw the motion under gravity. We discussed the concept of that. So today let's move on to the other part where we'll discuss the acceleration due to gravity. So we'll start with this, the acceleration due to gravity. The easiest way of determining the way for the acceleration of gravity is simply by observing the motion of a simple pendulum. So we'll get the acceleration due to gravity. You can simply observe this by observing the movement or the motion of the simple pendulum. This kind of experiment was first done by this guy, Galileo, uh, when he was studying the uniformly accelerated motion. So he did this by experimenting the motion of a simple pendulum. The simple pendulum is simply a small heavy body that is suspended by a light inextensible string from a fixed point, and it is normally used to determine the acceleration due to gravity. It is made by attaching a long thread to a spherical ball that is called a pendulum bob. The string is held at a fixed support, like two pieces of wood held by a clamp and a stand. So that's how this simple pendulum, how it is made. If the bob is slightly displaced to position B, we see from the diagram, it swings to and from going to C through O and back to B through O. O, that is the center. Now, when the pendulum completes one cycle, that is also known as the revolution, the time taken is what we call the period of the oscillation, denoted by capital letter T. So here is the simple pendulum. So here we've like this body suspended with this thread, and so the swinging, the motion, as you've seen being explained from the above side. So that's how this pendulum bob, how it is used to experiment the acceleration due to gravity. And so always just the point of suspension. And as you can see, these are just the motions of this a ball that is, or that is a bulb that is attached to this thread. The movement from A to C, then to B. At when the body reaches at B, for a time, it just gets to a rest, that it gets to a point of rest. So but before, according to the applied motion, you can see it swings from right to left. So that's how we are able to experiment the acceleration due to gravity. Now, from there, we'll see that we have a couple of definitions which they talk about the acceleration due to gravity. The first one, the period that we've seen, denoted as capital T. This period, this is the time taken by the pendulum bob just to complete one complete cycle. So complete one complete cycle, meaning that to swing from A going to B to C, then going back, it means a complete cycle. So that's the period. It's just the time taken just for this pendulum bob to complete one complete cycle. Then the angular displacement, this is the angle that is made between the string and the vertical axis just when the bob is displaced to a maximum displacement. So this is kind of angle that is just made between the string and the vertical axis. Vertical axis is that axis that starts from the top, that is the center, or across the thread. So the vertical axis, when the bob is displaced to a maximum displacement, whether at point A or at point C. So that's the angular displacement. The amplitude, this is simply the maximum displacement by which the pendulum has been displaced. The length of the pendulum is just the length of the string from the point of the attachment, as we've seen from the figure, that is point O, on the wooden piece to a center of gravity of the bob. Now, from the experiments, it has been observed that changing the weight of the bob and keeping the same length of the pendulum, the period is always constant, provided that all swings are small, though they may be different in size. Now, the period T of the pendulum is simply given by this kind of a formula: T equals to 2 pi r denote L upon G. So you can obtain T by this kind of equation. Now, where I is, I mean, L, that is the length of the pendulum, G, the acceleration due to gravity. Also, you can obtain it as by these equations. T equals to 4 pi r square L upon G, then resulting also to, you can get the L by simply taking equal to G upon 4 pi square multiplied by T square. So that's just the equations that you can use to obtain the various valuations there. Now it follows that if we plot the graph of L against T, it is going to be a straight line with the slope G upon 4 pi square and y-intercept equal to 0. And here is the graph. As you can see, the graph becomes a straight line. Now from there, when the bulb is raised into point B that is swing the at the center point, where point A is the at the highest point at the left part, and point C the highest point at the right part, as we've seen in the diagram. Now it will gain potential energy, and the bulb will swing due to the conservation of energy from the potential to the kinetic energy. Now at B and C, all the energy is the potential energy. So that's how it is, and at all energy is kinetic energy. Now, potential energy at B equals to kinetic energy at O. So you have to note this. And when if the pendulum swung in the vacuum, the oscillations just would have been continuous, because there are no these effects, for example, air resistance, which can cause the pendulum to go at rest. So if the pendulum that is swung in the vacuum, the oscillations just would have been very continuous. Now, but practically, air friction causes the losses of energy of the pendulum bob that can lead to the pendulum bob to go at rest. Now, that is why at a certain time the oscillation ceases. So that's what it means. Now, let's move on to the applications of the gravitational force. Gravitational force is applied in many elements of our daily life, though, and here are some of them. The first one that this gravitational force, it aids organizations and military aircraft just to use the gravitational force just to supply the food passes and other useful passes just to the needing individuals, especially those individuals who are at wars and they are in countries where there are conflicts. So the aid organizations and the military aircraft, they just use the gravitational force as to help to supply the food passes by releasing these food passes from the air, and the food passes just reaches to the individuals who are in need. Also, it used by the parachutists when they free fall from the sky. So the gravitational force is used by these people who like to use the parachute just to skydive. So they use the free fall from the sky by the application of the gravitational force. Also, we easily get fuels from the trees as they freely fall to the ground after they've been detached from the branches, and there it is, you can see the application of the gravitational force. Astronauts also, they can plan well their journey to the space by using the values of the gravitational force around the heavenly bodies in the universe. So gravitational force is very useful for these astronauts just to plan their journeys across the space by means of viewing the values of the gravitational force around the heavenly bodies that are there in the universe. So that's all I have for this session. I hope that's clear. We've seen the acceleration due to gravity. I've explained it using the simple pendulum bob. Then we've seen the various equations that you can obtain the various crucial parameters from there, the period, the length, etc., and the acceleration due to gravity also. Then we've seen the various applications of the gravitational force in our daily life. So I hope that's all clear, and thank you.